All right, this is section 2.3 notes, and we're talking about function notation and operations of functions. So let's start off with function notation. We have to talk about what a function is, how it works a little bit here. So for functions, we say for every x value that in the domain that is input into an equation, there's going to be a y value in the range that is output. Okay, so notice x value in the domain, that's our input, y value in the range, that is going to be our output. So the x value is like the money you put in the Coke machine, that's what you input. The y value is the Coke you get out, that's your output. Okay, so that being said, if any x value repeats, so if you use an x value more than once, then this is not going to be a function. Okay, so how do we read this f parentheses x close parentheses? How do we say this? Well, we just say this f of x, okay? And that simply means that f is a function of x, okay? So let's jump into some examples down here. Now for this little chart we have here, we have two functions. We have function f and we have function h. And so we have f is f of x equal to 3x minus 2. So anytime in any of these problems we talk about f, we're talking about the function 3x plus 2. And then anytime we're talking about h, we're talking about the function h of x equal to 2x squared minus 5x plus 1, okay? And, functions can be any letter. You could have g of x, k of x, I don't know, q of x, whatever you want. Here, we're just choosing to use f and h. But in any case, it means that these functions are functions of x because of these x's here. So our input is going to be that x value. So let's look at A here. We want to find f of negative 4. So our input here is that negative 4. So we're going to go over to our f function, and that's the one right here. And we're going to input that negative 4. So anywhere we see an x, we're going to take the x out and replace it with a negative 4. So it looks like this. We have 3. Instead of the x here, we're going to replace that with a negative 4. And then the rest of the function stays the same, plus 2. Now we want to evaluate this and just get a regular number for that. So we're going to use our PEMDAS rules, and that tells us to do our multiplication first. So 3 times negative 4 gives us negative 12, excuse me. That plus 2 comes on down. And now we can do our addition here. Negative 12 plus 2 will just give us negative 10. So f, the function f of negative 4, is going to be equal to negative 10. All right, let's look at this next one. This one we're going h of negative 3. So we're using our h function here. And so again, anywhere we see an x, we're going to take that out and replace it this time with a negative 2. A negative 3, excuse me. So we start off, let's say this is equal to 2 times x squared, but instead of x, we're putting that negative 3. And then we're going to square it. Minus 5 times x, but again, we take the x out and replace it with a negative 3. And then the rest is just plus 1. Okay. One more time, we want to evaluate this. We want to get a simple number and not all this mumbo jumbo. So let's use our PEMDAS rules to help us evaluate it. PEMDAS tells us we need to take care of our exponents first. So we're going to do this part first. So we end up with 2 times negative 3 squared. If you put this in the calculator, make sure you put that negative 3 in parentheses first. But when you square negative 3 times negative 3 should give you positive 9 there. All right. All right. Now that we've squared that number, let's go ahead on with the rest of the problem. We can do negative 5 times negative 3. And that'll give us plus 15, and we'll just carry down this plus 1. All right, PEMDAS tells us to do some multiplication next. So 2 times 9 gives us 18. plus 15 plus 1. Now last, if we do all that adding together, we should get 34. So our h of negative 3 is just going to be 34. Okay, so we plugged in some regular numbers. Now let's try plugging in something different. So here we're going to f again, but this time instead of an x there, we have a 5x. So what do we do with that? Well, we do exactly what we did like over here with the numbers. We're going to take out the regular x, but we're going to replace it with the 5x that we have here. So it looks like this. Remember, we're going to f, so we're using our f function here. So we have 3, and normally it's 3 times x, but instead of that x, we're going to take that x out and we're going to replace it with the 5x instead. So we have 3 times 5x. And the rest of that function is just plus 2. So I'm going to add 2 here. And now again, let's simplify and clean things up. We'll use PEMDAS, so we got to do some multiplying. So 3 times 5 gives us 15x plus 2. And that's it. It looks a little weird, but our f of 5x is just going to be equal to 15x plus 2. It's okay that there's still a variable there. We are done. Okay, so let's keep moving on to more different looking things. Now we got down here at D,